Kannadasan R. Hello everyone. Our topic is from the subject Programming Language Translators. The course code is CSC 309. This is our professor, Mr. Kannadasan Sir of SCSC department, VIT University. Our group members are Shrikar, Tarun, Dilip. The assignment questions given to us were: first one, describe the principal sources of code optimization. Second, find the predictive parser for the given grammar and parse the sentence. Okay, so first let us discuss about the first question, which was code optimization. So immediate code undergoes various transformations called optimizations to make the resulting code running faster and taking less space. Optimization never guarantees that the resulting code is the best possible. We will consider only machine independent optimizations, that is, they don't take into consideration any properties of the target machine. The techniques used are a combination of control flow and data flow analysis. Control flow analysis identifies loops in the flow graph of a program, and data flow analysis collects the information about the way variables are used in a program. A main goal is to achieve better performance. You can see the diagram which is below, which shows the source code as the front end, immediate code as the code generator, and the target code. Immediate code is machine independent and target code is machine dependent. There are two levels: machine independent code, control flow analysis, data flow analysis, transformation. Machine dependent code, register allocation, utilization of special instructions. Basic block. Basic block is a sequence of consecutive statements which the flow enters at the beginning and leaves at the end, without halt or possible branching, except at the end. Here we can see an example of the basic block. The figure shows B1, B2, B3, B4, B5 and B6, which is basically 6 blocks. And there are 30 steps which we have taken, assuming different variables such as I, J, T1, V, I, T2, T3, etc. Okay, principal sources of optimization. Local optimization, which is within a basic block. Global optimization, which is not in a basic block. Or we have also mixed optimization, which can be or without the basic block. Principal sources of optimization. These are the following methods in the principles of sources of optimization, which we will be explaining in brief: common sub-expression, copy propagation, dead code, and constant folding. Common sub-expression elimination. An occurrence of expression E is common sub-expression if E was previously computed and the values of variables in E have not changed since. To individuate common sub-expressions, we represent a basic block as a DAG showing how expressions are reused in a block. A DAG is a basic block, has the following labels and nodes. Leaves contain unique identifiers, either variable names or constants. Interior nodes contain an operator symbol. Nodes can be optionally be associated to a list of variables representing those variables having the value computed at a node. Copy propagation. After the assignment of one variable to another, a reference to one variable may be replaced with the value of another variable. An idea behind this technique is to use G for F whenever possible after the copy of F equal to G, for example. We can see the before and after change. Dead code elimination. A variable is live at a point in a program if its value can be used subsequently. Otherwise, if it is dead. A piece of code is dead if data computer is never used elsewhere. Dead code may appear as a result of previous transformation. Dead code works well together with copy propagation. Constant folding. Based on deducing at compile time that the value of an expression is a constant. Constant folding is the transformation that substitutes an expression with a constant. Constant folding is useful to discover dead code. Let us take an example. Consider the conditional statement if x go to L. By constant folding, we can discover that x is always paid and we can eliminate both the if and jump to L. Loop optimizations. Beyond basic block, there are three important techniques: code motion, induction variable elimination, and reduction in strength. Code motion. Move code outside the loop since there are potential many iterations. Look for expressions that yield the same result independent of the iterations. Let us take a code as below: before, while, and after. The conditions are taken. Induction variable elimination and reduction in strength. Look for induction variables for strength reduction. Example, a pattern of changes in a log step. Let us take a block 3 and take variables for j respectively and solve. Reduction in strength. Replace costly operation with simple one. Shift, add instead of multiply or divide. Utility is machine independent. Depends on cost of multiply or divide instruction. On Pentium 2 or 3, integer multiply only requires 4 CPU cycles. Recognize the sequence of products. For I equal to 0, I less than n, I plus plus. For j equal to 0, j less than n, j plus plus. A ni plus j equal to bj. Int ni equal to 0 for I equal to 0, the same condition, and ni plus equal to n.
I'm going to discuss about the second part of the question, predictive parsing, the steps to be followed before performing. Predictive parsing, no left recursion and left factoring should be present in the grammar. Find first of alpha and follow of alpha. Construct predictive parsing table. Check the input string parsing table. These steps have to be followed for doing the above problem. Given grammar, S implies A, T implies T, comma, S or S. Step 1, there are actually steps to be followed. The first step is remove left recursion. In the given grammar, we can find the left recursion in the production T implies T, comma, S or S. So we have to remove the left recursion in this given grammar. Now we should remove the immediate left recursion. Steps to be followed for removing left recursion are, this is the table which is to be followed. A implies A alpha or beta, then A implies B A dash implies alpha A dash or E. Now we have been removed the left recursion. When we compare the production with the above steps, we get T implies T, comma, S or S. Now the left recursion is being removed. Now after removing the left recursion, we get T implies ST dash and T dash, comma, and T dash implies ST dash or E. The new grammar is S implies A, T implies ST dash, T dash implies S, ST dash or E. As we observe the above grammar, we can conclude that there is no left factoring and left recursion. So we conclude that the left recursion and left factoring has been removed. Now the step 2. We need to find the first and follow. First of S, first of T and first of T dash are respectively given, and follow of S, follow of T and follow of T dash are respectively found, and we can now find follow of S, follow of T and follow of T dash. Follow of S is as follows. Follow of T and follow of T dash are as follows. We have to follow the regular procedure to find the first and follow in this grammar also. And after finding the first and follow, the next step is to construct the predictive parsing table. So now we have to construct the predictive parsing table. Now construct the parsing table. In this table, all the terminals will be represented as columns and the non-terminals as rows. So the terminals are as follows, and the dollar should also be included in the column. This is the point to be noted. Non-terminals are S, T, T dash. Now this is the parsing table which is constructed by the given grammar. So with the help of the first of alpha and follow of alpha, we can construct the table. If first of alpha produces the terminal, the main production should be placed in the column of the corresponding non-terminal. If there is an E in the first of alpha, we should place the production in follow of alpha column. Follow of alpha is the follow of LHS of the particular production. Now, as we have constructed the passing table, we should pass the given grammar. This is the grammar which we found, and the constructed passing table is this one. So, with respective passing table, we have given the stack, input, and output. For $s, the input is as follows, and the output is as follows. We can say this by looking at the passing table. This is the passing table which we have created, and the stacks are follows: $T, $SE, and the respective input and outputs are given. And we will repeat the same step until all the C are removed. So we have to note this point. And then after finding this $S and $S, by this step all the C's are removed. So we have to make sure that these two steps are repeated and followed. And now repeat the same procedure till you complete the respective pass tree. And now in the same way we do the above steps until only dollar symbols are left. If we have anything other than dollar symbol, then the string is not accepted if only dollar is present. Okay, now by looking at the passing table we get output as S implies A. So we have to follow the same procedure until all the characters in string are deleted and only dollar is left. Then we can say that the string is accepted. So we came to know that only dollar should be left in the pass table so that it will be accepted. Thank you guys for watching this video. If you like this video, please like button below and subscribe it. This is a presentation by the students of VIT University.